at the end. All right, so we can get started. If you could flip to the first slide. I'm just going to give you a little overview on the College of Northeastern University itself. So we are a top-ranked Research One and experiential learning university. This just simply means that we are in the top tier of both research and experiential learning, according to US News and World Report. For this year, we are ranked #1 in co-op and internships, which we'll talk about later in the presentation. In addition to the College of Engineering, Northeastern also has 9 other colleges and schools throughout our network. We do have over 50,000 students, of which about a fifth of those are engineering students. We do offer degrees from the doctorate down to the bachelor's degree, and the university receives about 296 million external research awards each year. While this program and most of the programs in the university are located in Boston, we do have 13 different campuses across the global system. On this page, you can see 9 of those campuses. This is just to show you where your other student colleagues in the College of Engineering may be studying. Again, for pharmaceutical engineering is just located in Boston, but this is just so you can see our whole network. Next. While the pharmaceutical engineering program is located in the Department of Chemical Engineering, I just wanted to show this screen just so you can see the diversity of programs that we have and the diversity of departments we have in the College of Engineering. So again, some of your student colleagues may be studying more of our disciplinary programs, some may be in more of our multidisciplinary programs, but this program is in the Chemical Engineering Department. Next. These are just some numbers on the College of Engineering itself. We have over 10,000 students just in the college, so this is about a fifth of the entire student enrollment for the entire university. We'll see on the screen there that COE is actually primarily graduate students like yourself, and the majority of those graduate students are going to be MS students. We do have PhD, MS, and BS degrees, but we also have other offerings such as graduate certificates for those of you who are graduate students, and for undergraduates, we do have minors. So overall, we have 110 academic offerings in the college. We do have 400 full-time faculty. Most of those are tenure or tenure track, although some are faculty of practice who are not on that. All of our faculty bring with them a wealth of knowledge. Some have worked in research, some have worked in industry, and they're all here to support you as you go through your learning journey. For research, the college receives over 100 million external research awards each year, and this is up 35% since 2020. And our US News and World rankings have just been updated, so you can see those in the corner. As of this year, we are the 34th best engineering graduate school. Next. So this is just to show you the academic programs in the college is broken up by the network. You can see that we have some programs, a lot of programs in Seattle. Some of these campuses are new and emerging, but all of these do support the College of Engineering students. For our numbers, we do have 9 PhD programs in the college and 32 MS degrees, but we do say that the MS number is always changing, so don't get too used to that MS number. Next. And just before I hand it off to faculty, I just want to show the COE mission. Our COE mission primarily focuses on the people who are studying and the work that they are doing rather than just the product. So you can see the mission there. As an academic institution, our main product is people. Our success is based on the quantity and quality of the people we produce. So we say in the College of Engineering, a good engineer solves problems, a great engineer solves important problems, and a transformative engineer discovers and solves important problems. And we really hope to educate you as a transformative engineer if you come and study with us. So with that, I will hand it over to faculty and they can talk about the next part of the presentation.
Hello, everyone. Welcome. Glad to have you join us today live or watching the recording afterwards. So we're going to talk a little bit about the Department of Chemical Engineering, but specifically the Pharmaceutical Engineering MS program. And joining me today, we're going to have also fellow faculty member Brian Lejeune, as well as myself. So we are both teaching professors in the department, and I'm also the Associate Director of MS programs. And then we'll also have Mallory Moffett, who is a current PhD student and one of our COE student ambassadors from the department. We got some fast facts about the department this academic year thrown up there. So we are about 25 research active faculty, and we have additional faculty beyond that. We're around 100 PhD students, around 50 master students, and around 400 undergraduate students. So that's the size of our department all together. The MS programs include pharmaceutical engineering as well as chemical engineering master students. And over 300 of our students have completed a co-op just in the last year. And most of our undergraduates and even most of our master students do co-ops, and that includes pharmaceutical engineering. So we are located here in Boston, Massachusetts, and so we really like being here, especially for pharmaceutical engineering. There's hardly, you could hardly imagine a better place in the world to study and learn pharmaceutical engineering and biotech in general. And we have lots and lots of great companies and startups from many small startups to a lot of big biotech and pharmaceutical companies as well. There's a lot of innovation here and a lot of companies that you can potentially work with, and of course many partner institutions throughout the region as well. So we're really a city of learning. So I want to first here play a short recorded video for you. This is on the university model at large.
Our approach to learning is very simple, very powerful, and very impactful. It's called experiential education. It helps you integrate the classroom experience and the world experience. You're not only thinking, you're doing, and you're bringing the two together.
Co-op got me to see the real world application of what it is that I'm learning.
You get the more structured class learning to really get the initial concepts in your head, but then you get a chance to go on co-op and actually getting your own hands-on opportunities to try them for yourself.
And that just getting to swap back and forth between that it's intoxicating, honestly. It was like, it allows you to hone all these different skills at the same time.
You're coupling their new theoretical knowledge from taking more classes with their increased lab experience, and it's really powerful.
I was able to learn the process of research, which was cool, much different than a lab experience. Although a lot of the stuff I learned in lab, I was able to take with me.
To now be able to know exactly what questions I need to ask, what research I need to do, and just hit the ground running.
They gain a level of confidence that they wouldn't have necessarily received had they not had that professional experience. They also gain this level of professionalism that I see gets translated back into the classroom.
I think I understand how to study better and how to learn better and how to apply what I'm learning into different applications that I think I might have had a disconnect with.
I have a high hiring bar. The program and the results that we see in that time is we can't compare it to anything else.
If my advice go to the International Co-op Office, they'll help you find one in Asia. We have many students doing co-ops in Asia.
So it was kind of interesting just to see the values in China that some of the patients had, the families had.
Being in Portugal really helped me develop my language skills.
Realizing that there's so much more out there in the world. I think Northeastern caters their program to allow each student to have a lot of flexibility.
You really make your own experiences.
That was a little bit about Northeastern in general. We really do emphasize the experiential education model a lot, not just through the co-op program, but also through our course curriculum offerings as well. We'll see a little bit more about that later. Next, I want to play a second short recorded video, and this one is specifically looking at the Department of Chemical Engineering as a whole. So that's inclusive of PhD, MS, and as well as pharmaceutical engineering.
Chemical engineers can solve any of the world's challenges. Climate change, health, medicine.
How do you build a sustainable world? All these different things that our future as a planet depends on, everything can tie back into chemical engineering.
The master's program is really coursework or research, where you get a little bit more in depth than you did as a bachelor's student. And then the doctorate is really all about research.
Research facilities here at Northeastern are great. We have world-class equipment and capabilities.
My research focuses more on examining the endothelial calyx in organ-specific cancer metastasis. It affects many people. Many people have died from it. And so obviously there's just a need to find a cure.
Batteries, they produce a lot of heat. And if we're going to put it into an electric vehicle, we have to get different ways of removing that heat efficiently. Otherwise, we're going to see them flare up. My research is how can we improve polymer materials? How can we make these battery packs safer? And how can we make them more cost effective?
We spend a lot of time thinking about what allows our students to be their best selves and to pursue their own dreams and their careers.
Northeastern has the experiential model.
You're in charge of your own project. You have your own timeline that you create and the goals that you want to do.
We're embedded in this ecosystem that is really looking at how do we advance technology for health, for energy, and for climate.
Boston is a biotech hub, so there's so many pharmaceutical companies, and I was thinking about future career opportunities when I decided Northeastern.
That idea of finding where you want to be is just experiencing something before you do it and commit to it is just a really exciting opportunity. And so we encourage our students to do co-ops.
And then they come back with new knowledge and they've learned things that I wouldn't even think to teach them.
My co-op is at Rogers Corporation. When you get back into the field, you know exactly what to do because you've seen that before. You have the thought process down, you know where to go.
What's so great about Northeastern is there's so much collaborations between different departments.
This is the most supportive community I've ever been in. Academically, professionally, personally, there's always someone there to support you and they just want to see you succeed.
Okay, so now we're going to start talking about the pharmaceutical engineering program in particular. But first, I want to highlight an additional offering that we have, which is an opportunity for students in the pharmaceutical engineering program or in the chemical engineering master's program to sort of add on while you're here. And that is to add on a process safety engineering graduate certificate. So the idea here is that this might cover really critical skills for both safe and responsible process engineering, so that you're not just able to go out and work in a pharmaceutical company, design processes, but design processes that are going to be safe, that are going to be sustainable, and are going to really work well in the context of your corporate culture. And so this is 12 semester hours in total. So it's 8 hours in process safety and then 4 hours in process engineering. So one of your core pharmaceutical engineering courses counts for this, so you can stack it on by basically utilizing your elective credits to study process safety. And so this can also be completed as a standalone program, but if you do that, it's not eligible for co-op or internship, and you can also take this part-time. So the courses here, right, so we have the option here that you would be most interested in, which is process safety engineering for biotechnology and pharmaceutical industries. So we typically offer this in the fall semester. And then in the spring, we'll offer a computational modeling and process safety. So you get both some of the foundation in your disciplinary area, as well as advanced engineering tools that you might want to use. And then, of course, process engineering electives, which pharmaceutical engineers would take this pharmaceutical engineering 1 already. So now on to pharmaceutical engineering MS program itself. So what's the program all about? Well, the program is about trying to bring together 2 disciplines. Really, it's more than 2 disciplines, but 2 primary disciplines in chemical engineering and pharmaceutical science, so that we can help better position and train new engineers or engineers that are refocusing into the pharmaceutical realm towards this with both foundation in chemical engineering and engineering skills, but also in pharmaceutical science. So it's unique, it's interdisciplinary. We don't have very many cross-college MS programs at the university. This is one of the few. And it is still housed inside the chemical engineering department. So you would be a student in the chemical engineering department, but also taking classes and meeting and working with pharmaceutical sciences faculty. And so who is this for? Well, it's really for engineers looking to refocus into pharmaceutical sector. It's for also scientists looking for engineering focused career opportunities, and people just currently working in the field that want to gain more skills in that particular area. So what we really kind of expect coming into the program in terms of prior preparation are a few things. One, we expect that you have some math. We don't require as much math as we do for our MS in Chemical Engineering program, but we do want to see students that are prepared in terms of having taken differential equations and calculus 2. And if you haven't taken those yet, and you're looking at joining us in the fall, you can still try to take those courses on your own over the summer, or we do offer a transitional mathematics class this fall that you could take to get up to speed on those classes and those math skills. Really, because our pharmaceutical engineering courses from the chemical engineering department dive straight into working with differential equations as applied to process design and engineering. We also, it's not required, but it is beneficial if you've had some exposure in terms of organic chemistry and biochemistry and molecular biology. And some of you may have had some of these topics before, or maybe not all, but if you need a refresher or need to really learn some of the basics in this, we also have a course offering in the summer that's an online 2-semester-hour course in foundational biochemistry for pharmaceutical sciences. And so that's offered through the Pharm Sci department. And if you want more information on these, if you enroll in the program and commit to coming, then you'll receive registration guidance that will detail exactly which classes to register for. So the structure here is 32 semester hours in total over 1.5 to 2 years as a full-time student. If you are working on this part-time, it may take longer, but you can do that. We do have part-time students that might take 4 to 8 semester hours each term and slowly work through the program. Maybe they're working full-time at the same time. And the core coursework is split, as I mentioned, between really 10 hours in chemical engineering and 8 hours in Pharm Sci. And these include both theoretical classroom, lecture style courses, as well as lab classes. So you'll take a Pharm Sci lab class as well as a pharmaceutical engineering lab class. We'll hear a little bit more about some of those in a bit. And then from there, you take elective coursework in regulatory, quality statistics, and then this broader open depth category, which is where you might be able to count, say, our transitional mathematics class or process and safety engineering courses or that foundational biochemistry course. All of those could be counted towards this depth elective category. And of course, you can do co-ops and internships. We've had a number of our students doing this already, completing co-ops, and we are graduating our first class of this program this semester. The idea is that we launched this program really in response to industry needs that we saw and market demand and 2 years ago. And so now we are looking at bringing in our third class in this program this fall. So of course, you mentioned co-op opportunities. We have lots and lots of big name companies all right here in the area. Most of them do an awful lot of their research and development work in the area as well. And it's really the best place you can be to study pharmaceutical engineering. So in terms of our required courses, I mentioned them briefly, but we've got 2 8-semester hours of lecture course. So this is theoretical, so it's upstream and downstream pharmaceutical engineering operations. And then we have our lab. Then we've got concepts in pharmaceutical science 1 and 2, as well as the Pharm Sci lab. So those are the core courses that would be taken. So now I'm going to turn it off to Brian Lejeune, who is one of our instructors in the Pharm Sci lab, pharmaceutical engineering lab, and he's going to tell us a little bit more about these pharmaceutical engineering courses.
Right, thanks, Adam. Yeah, so I guess just reiterating a little bit of what you've heard so far, that the goals here with this program are to kind of narrow down the focus to some extent of what you might potentially have opportunities to to do as a chemical engineer, or maybe you are trying to break into the pharmaceutical industry, where really we're taking the core principles of chemical engineering and we're applying them specifically to the context of biopharmaceuticals. So what that looks like is, for instance, kinetics or transport, which are, subjects that every chemical engineer learns about. Now, what we're doing is we're applying those to growth kinetics within bioreactors, for instance, or enzyme kinetics. For heat transfer, we're thinking about now how that specifically applies to how we can maintain a particular temperature inside of our bioreactor culture, or how heat transfer might impact protein binding or stability. Next slide. In terms of mass transport, we learn about how oxygen transport is very important to cell metabolism and growth, and how that impacts the ability for our microbes to efficiently produce proteins or biologics. And then fluid flow, whether it be from from centrifugation to how we harvest and separate our materials in order to go from culture to our final product. So thermodynamics are also very important, and here we might specifically target things like protein crystallization, again, chromatography, where we're thinking about how our proteins are interacting with a particular resin for resin selection, or how we can recover the most protein possible, which is in the end, most of the time going to be our final product. So as Adam mentioned, our courses assume that you have no prior engineering background. We have, I've taught students that were undergrad chemies that are already working in industry and are looking to specialize a little bit more. And then I've taught students that, have a scientific background, but have never taken an engineering class per se. So, we don't necessarily assume everything, and we're working to build that foundation from the ground up. But as Adam mentioned, assuming that you have a strong background in differential equations, so that you have the math skills that are foundational for developing the equations we'll use to create models, so that you can, kind of take that next step as someone with a master's degree once you graduate, and being able to lead projects, to make informed decisions rather than just as an operator or technician. Overall, we have an emphasis on, quantitative understanding. So specifically in the course that I teach for the program, which is the lab class, you're learning to run bioreactors, you're learning to purify proteins with FPLC, but it's more than just operating the equipment, right? We're taking the data that you're actually getting as an output, and we're using that to create models so that we can make those informed decisions to figure out how can we optimize as engineers. And we do that through computational approaches like problem solving and modeling using Python, which you'll learn kind of along the way. So in terms of the lab class that I teach, this is team-based. This semester, I've kind of had it broken up so that you get to work with a few different teams throughout the semester. But the main components are, there's an upstream aspect where we're looking at cell growth, and that starts in shake flasks, and you'll develop some skills, just basic good lab practices. And then we move on to bioreactors, where we have more opportunities for controls and data acquisition along the way, and optimization of cell growth. And then from there, we move to downstream aspects where we're using chromatography in order to purify proteins. And we look at resin selection and, perhaps the different speeds that we're running our equipment in order to try and get protein, which is purified, and then we'll end with kind of some analytics there to quantify that through STS page and protein and some assays to understand what our protein concentrations are. So here, these are just a list of some of the elective classes. Adam mentioned that there was a regulatory component, which is obviously really important in the biotech industry. So these are just a number of the options that you'll have to take that you can select from for that regulatory requirement. Also quality and statistics, where, I think part of, if for those of you that maybe have never, done much lab work previously. One of the important things in the lab course that I teach, and then kind of beyond that, is really being able to discern whether variations in data are significant or not, right? And this statistics requirement will also help with that to make sure that you can design experiments effectively. And then understand what might just be variability and noise in your data versus something that's statistically significant. And then Adam also mentioned this depth requirement. So here you can see that there are a large number of classes that are offered throughout various departments. So we have, you can kind of see the home department based on the course number here. So, biotechnology, chemical engineering, and pharmaceutical science. And then pharmacy as well. So there's a number of different schools and departments where these depth requirements come from. And yeah, just kind of talking a little bit about the job market. I wanted to just go back to this idea that you saw kind of in both of the videos and throughout the beginning part of the presentation, that there's this experiential component, and this kind of starts it might start in the lab class. It might start in reaching out to faculty on campus where there might be opportunities for you to do research in a lab on campus. And then there's also the internship program where we have, a strong network of, co-op employers within the biotech industry that's been established for over 115 years at Northeastern. What's nice is that you don't really have to go too far to tap into the job market and the co-op companies that are already established with Northeastern, living in Boston. So here you can kind of see some numbers where the Massachusetts biopharma industry has been growing kind of annually at a rate of 7.7%. And that we are estimating that the job market is strong. We have over 285,000 jobs in Massachusetts that are related to the biotech sector. And here you can see some statistics on chemical engineers in the pharmaceutical industry, where both mean and median salary are over $100,000 a year, and this was as of a couple years ago. So, I highly encourage you to take advantage of the experiential components. I think that's one of the strongest parts of the degree offering that we have here in the department, where, the theory is great. And I think even if you have a background in chemical engineering, that, maybe what you've learned has been more on the theoretical side. And when you actually are able to couple this with, lab experiences where you can then, collect data to then analyze, it makes a big difference and really prepares you for what industry is looking for.
All right, so now we would like to hear from our graduate ambassador, Mallory Moffett, to tell us a little bit more about being a graduate student in the department.
Good morning, everyone. So something that our department has that a lot of different COE departments have is a graduate student council, which their job is to be the bridge between students and faculty. So they put on a number of different events, either social, so a lot of them are listed here, as well as some professional development ones, and then just providing opportunities just for us to be more of a community. All the new officers are pictured on the right there. They're really great. And then on top of events that are put on by the student council. There are a number that are put on by the communications lab, and those are some that are listed below. And then I forgot to mention that our student council also strives to give back to our community. So there are a number of different volunteering events that occur throughout the semester as well. Outside of our department's student government, there's also the College of Engineering PhD Council. They put on events throughout the year as well, including a weekly coffee hour. So you can meet a bunch of different students outside of the department, which is really great. The Com Lab offers the weekly webinars and in-person events that were on the previous slide, as well as offering like one-on-one assistance in terms of writing. So if you're applying for fellowships, they're a really great resource. There are a number of different student organizations listed here. One that I don't think is listed here is also there's a biomaterials society. So there are a lot of different ways that our students are involved on campus. Additionally, Northeastern's very much known for co-ops. There are a bunch of really great opportunities for that, including co-op. There's coursework that you have to take, and then they put you with your own advisor, and they can assist you with making sure your resumes look good and assist you in finding a placement. On top of that, if you're an international student, the Office of Global Support, or OGS, is super helpful in terms of learning more about what you need to do in terms of visas and how to best prep coming to campus. And then I can personally vouch for the last bullet point here, the career design. There's a Canvas page dedicated towards teaching you how to network and other sorts of soft skills that are really helpful. And that's just a Canvas thing that you can do at any time. It's kind of go at your own pace. So there's a lot of different resources on campus for students to be successful. And then finally, just to get you guys in the know about the graduate ambassadors as a whole, we have a website. So if you're interested in any other departments, you can find the ambassadors for their department. You can reach out to them, ask them about their experiences. We're also on social media. There are WhatsApp groups where you can ask questions, again, directly to students. And then if you're admitted, you can meet your other cohort members. Or you can just email our joint email, which is listed here. And then those usually get forwarded to whomever the emails best pertain to. And then just a quick blurb about myself. I'm a third year, started in 2022. I originally had a degree in biomedical engineering. So I think if anyone has any questions on what it's like to switch from a different discipline of engineering into a different field, I'm happy to answer questions about that. It's not as scary as it seems. I work in Allison Dennis's lab, where we focus on bioimaging and biosensing, in which my personal dissertation is working to improve cancer imaging modalities with fluorescent imaging. Outside of work, I do yoga. I'm training to be an instructor. I like to upcycle clothing. And then outside of that, I served as the GSC president last year. So I have a pretty good idea of what events are going on at all times. And then I'm serving as the ambassador for this. So feel free to reach out if you have any questions about living in Boston, what it's like to be a part of our department, and other sorts of things like that.
All right, thank you, Mallory. And we encourage you to stay connected, right? Reach out if you have questions, speak with the ambassadors. You can email me, certainly. And you can go online and look through our faculty directory and see all of the members of the department and get interested in things that they might be doing. We have a number of faculty that do research as well in pharmaceutical engineering context. And then we'll turn it back to Marissa here to talk about next steps.
Great, thank you so much. So on the next slide, you'll see sort of our roadmap if you are an admitted student. So if you are on the call today or you're watching the recording and you've already been admitted, I just want to first extend a congratulations on your hard work and for getting into the university. And we're very much so looking forward to seeing you in Boston in the fall. So just a couple things I want to point out on this. First of all, this has been developed by our student ambassador team. So students just like yourselves made this just so they hit the important parts that they felt would help you as you are coming into the university. So the first important part I want to hit on is before you can do anything else on this roadmap, you first have to let us know that you're coming and that you will be joining us in the fall. So please make sure that you submit your enrollment deposit and you fill out your enrollment survey. All of that will be in your Slate portal, which is where you applied for the program. So just make sure you do that before you do anything else. Once you tell us you're coming, that will kick off some other important steps, such as activating your Northeastern account. So you'll get an email from help@northeastern.edu with your online credentials. If you're an international student, this will be the login for you to complete your I-20. So just make sure you do that. In the meantime, you can also start looking for housing. I will have to say in the Boston area, most leases do come up either in August, but the majority of them will come up in September. So it's always okay to start looking for those kind of things ahead of time. A lot of places in Boston will start advertising openings in the May to August timeframe. So just keep that in mind. We do have an office of off-campus housing who can kind of point you in the right direction if you're having trouble looking for housing, but then also the student ambassador team. A lot of them were new students in the Boston area as well, so they can also give you some tips and tricks. You'll also have to plan for orientation. You will have both a student services orientation put on by our academic advisors, and you'll also have your program orientation. You'll also have course registration. So I believe course registration guidance for fall has already been posted on our new student page. Make sure you please read over all of that just so you're registering for the correct courses as you're incoming. And then you won't be billed for your tuition until you are able to register. So registration does open next month, so you won't be paying any tuition until after you register. And then finally, as you're preparing to come, if you are an international student, you will have to check in with OGS. And lastly, for all students, just please make sure that you complete your admissions file by submitting your official transcripts and your proof of degree. Next. If you're a prospective student, there's still plenty of time to submit your application. So if you're interested, please feel free to submit that. If you're an international student, you have until June 1 to submit your application. And you have until August 1 if you're a domestic student. And you also have July 1 if you're an international student in the United States. And then we also have spring deadlines on this page as well. Students who are international can apply until August or October 1, and students who are domestic can apply until December 1. And then quickly, our admissions requirements. For fall 25 and spring 26, there are no application fees for any of our MS programs. You are required to submit 2 letters of recommendation. Please just make sure that these are folks who can speak to your academic work and your ability to do well in the program. So we just ask that you do not use friends, relatives, or anybody who does not know how well you could do in the program. We only require unofficial transcripts for the application, 1 statement of purpose. We require your official resume. And if you're an international student, we accept the IELTS, TOEFL, or Duolingo as proof of English proficiency. And then lastly, we do encourage you to keep in touch with us. Please make sure that you are constantly checking your application. If you are in the application process, you can check your status right on the application page. We also have a robust FAQ page. So if you have any questions and you're a little hesitant to reach out, which we hope you're not, we're always encouraging you to reach out if you have questions. But if you don't want to reach out, it's likely somebody has asked your question before, so you can look for those. You're always welcome to reach out to the admissions office if you have any questions. And of course, if you have any questions about what it's like to be a student, you can also feel free to reach out to the student ambassador team. So if there are any lingering questions, please feel free to put them in the Q&A. We're here for you if you have any questions, but if not, we'll give you a couple of seconds, but we can wrap up the webinar as well if nobody has any questions. Right. Since I don't see any questions in the Q&A, we can wrap up. For the students who stayed until the end. We will be we will be sending out the recording. So thank you so much for attending, and we hope you all have a great rest of the day. And thank you to our panelists for joining today.
Thank
Thanks,
you.
everyone.